All right, let's go ahead and do this. We're going to go ahead and demonstrate Boyle's law. For starters, you'll go ahead and need a complete syringe, obviously minus the needle. That shouldn't be an issue. It typically comes in two parts. And you'll need a fresh marshmallow. The stale ones typically don't work as well. So as teacher to teacher, let's go ahead and get started. First, we'll go ahead and put the marshmallow inside of the syringe. Just a quick note, as you push down the stopper, make sure you don't actually touch the marshmallow, because what will happen is you'll actually get it stuck in here and then you ruin the whole syringe. It's kind of a bummer. Replacing marshmallows isn't a big deal, but replacing syringes can be. So what we're going to do is go ahead and demonstrate Boyle's law. Step one, since we know that it's P1V1 equals P2V2, we're going to make sure that temperature stays constant, because it needs to do that in order for Boyle's law to work. So what we're going to do is first go ahead and start to get our closed system here. And now that we have a closed system, we're going to go ahead and increase the volume. So now as we increase the volume of our system, we'll actually notice that the marshmallow inside is actually getting bigger. And once I let go of the closed system, you'll see that it goes back to its normal size, which is really cool, and the students find this pretty fascinating. What I'm going to do now is go ahead and obviously with an open system, I'll go ahead and pull the stopper back. Then I'm going to go ahead and create a closed system. Now what we're going to do is we're going to go ahead and decrease volume. So now as we decrease volume, what actually ends up happening is the marshmallow is getting smaller. And hopefully you can go ahead and see that on the screen. I'll go ahead and make it an open system, and you should see the marshmallow go back to its normal size. Oh, there it is. So what happens is we know that since pressure and volume have an inverse relationship, I've been talking about increasing or decreasing volume, but really what we can do is use pressure as a substitute. So what we can do is we can also, once we have a closed system, we can say that we're going to decrease pressure. And as we decrease pressure, we see an increase in size. And then once we get a closed system, we can also say now we're going to increase pressure. And as we increase pressure, you can see that that little marshmallow is getting tinier and tinier and tinier. Okay. And what ends up happening is you can hopefully see on my finger, there's that little dot, from the pressure. But certain syringes you can actually buy with a stopcock, and it'll attach here. It'll be a threaded piece, and you can keep the valve closed or open, so not have the travesty of an injured finger. So what happens is, as you'll find on the web page, we talked about what happens if you increase or decrease volume and increase or decrease pressure. But really, you're actually doing two things at once. So as we showed, as you increase pressure, you're actually decreasing volume, and as you increase volume, you're decreasing pressure. And the air pockets inside the molecule truly show that. So if you have any questions, you can always email me at coachshano@gmail.com, or be sure to check out the website. Hope this finds you well, and this has been a demonstration of Boyle's Law. Thank you.